going to be talking about basically all the things that we've used to build OpenShift, a lot of which are Puppet Labs technology, Puppet, MCollective. And one of the things when I started building this, I was conflicted, because my background is IT. Actually, before I was running engineering for OpenShift, I worked in IT for a long time. I was on pager duty, all those sorts of things. And so we've used Puppet at Red Hat since Puppet was like Luke and nobody else. And so I'm very comfortable. Usually I go out and I talk a lot about Puppet. But I figured this audience, which seems like it was a good bet, is I could bring a little bit more value by talking about the things we do beyond Puppet. So for us, OpenShift, I don't know, just out of curiosity, how many people know what OpenShift is? Oh, that's fantastic. OK, so I'm not going to talk about that too much. OpenShift is basically, it's a platform as a service. And if you don't know what a platform as a service is, to really super simplify it, if you're on the app development side, we try to make that easy, magical, if we could. One of the differences with OpenShift is that it's not hosted only. You can pick it up and install it yourself. And so we don't just cater to developers. If you're on the operations side, we try to make managing systems easier as well. So that's our challenge. That's where we are in the space. But that's where we started with OpenShift. Those were our goals there. And getting back to the Puppet thing, my hope was this, if I bring this up, it looks familiar to you guys, because I'm not going to talk about it. That is usually, I talk a lot about Puppet syntax, how we use it, but we don't really use Puppet in exotic ways. We use Puppet very standard, deploying VMs and those sorts of things on OpenShift. But I asked before, and there were some hands that weren't raised. If I was going to summarize Puppet, because I don't want to ignore it, this is very powerful technology, if your config approach looks like this, and where you're copying files around, you're using sed and replacing various config strings all over the place, and I can sort of make fun of this because I've written plenty of code like this before in IT. Moving from this style to Puppet is going to be earth-shattering for you. And that's about all I will say about Puppet, because it's pretty well known. It's well known in this space. We use it. And on OpenShift, we use Puppet in a fairly standard way. This is a link to our Puppet modules. And to sum up what we use Puppet for is we use Puppet to set up new VMs. We provision them. We're hosted in Amazon. We provision VMs. We hand it off to Puppet. Puppet installs packages, sets it up. Basically just the same way that I used Puppet against bare metal machines. And so that wasn't as interesting of an area for us. But one of the interesting things on OpenShift is when we started, we had to choose, what were we going to focus on? And we chose actually not to focus on the VM model. We were going to focus on Linux containers more than virtual machines. And that brings up some interesting problems there. And one of the reasons for that was we were running a free service for the world. And we still do. We have a free level. We'll give you 3 things for free, anyone with an email address. And if we spun up a VM for every single one of those apps, and Brian talked about this more, we deployed over 1 million apps at this point, and we deploy thousands a day. Amazon would be the happiest company with us ever, because we would be by far the largest consumer. But that cost model doesn't work for us. And so we needed a way of, even small VMs, we needed something smaller and more volatile, but that wasn't going to kill operations, because we still had to manage this. We ran it like a 24/7 team from day one, even when we were in developer preview. So I have also grown to hate the term Linux containers, because everybody I talk to in the space, it means something a little bit different. So before I get into what we're using to orchestrate them, I figured I would talk to what we think of as Linux containers. And it's one view, and it's neat, because the technology is evolving like crazy. But it does have the unfortunate side effect that it means something different to everybody else. So I'm going to probably use 2 terms in this that are OpenShift specific. You'll hear me say gears, and you'll hear me say cartridges. And I'm going to try to minimize that as much, because I'm more interested in the MCollective and Puppet tier. But I know it's going to come out of my mouth. So I figured I would start here. Anything I say with gears, just replace it with containers. That's really what I mean. We had to brand it uniquely because containers was becoming too mystical in the industry. It didn't mean anything concrete. So Gears was our way of doing containers. And a container is sort of like a VM with nothing installed on it. There's not much there. And cartridges that's our term for what are we going to put in this container and run on it. So terminology, you should be set. I know like this is in my blood. I will say these things, but I'll try to keep it to the base technologies. So a container to OpenShift, kernel namespace segmentation, control group workload management, and SELinux. Now this is the real curious question. How many people in the room have any idea what kernel namespaces are? Show of hands. Okay, that's good. That's actually, usually it's nothing. What about Linux control groups? More? Okay. SELinux, and you can't just have heard about it, you have to actually be using it. Okay. No, it's set enforce 0 does not count. That's not a valid usage. I will talk to that. Okay. So that's good. And I'm going to touch on these a little bit because the concept of containers for us is really what drove us to MCollective, where it was a different way of everything that we approach, from how are we going to spin stuff up to what's the operational impact. But let's talk about kernel namespaces first. And this is going to be oversimplified. If our kernel team was here, they would yell at me and say I'm making this too simple. But I like to think of kernel namespaces as very similar to traditional Japanese house walls, where they're elegant, they're modular, they segment people nicely. But on the other side, if you put effort into it, you're going to be able to break through one of these walls. They're much better at segmentation than they are at true security. Kernel namespaces falls into that same boat. And sorry for the resolution, it's a little long, but kernel namespaces, there are a lot of them, from file system, from mount namespaces, UTS, host name, process, network, user IDs. But you can sum all this up to their goal is to make your little container look like its own machine. And everything from the host name that you check to your process ID is the same. That's kernel namespace in a nutshell. Second thing is control groups. Control groups, like we use them to try to make our processing highways run like this. We don't want traffic jams. We don't want bottlenecks. And control groups, they're there to pick, how many resources am I giving to everybody? And when there's contention, who's going to win and who's going to lose? So like if there is a traffic jam, I want to make sure there's some quality of service involved. Okay. Control groups, very similar. Lots of subsystems. And you can really simplify this to controlling everything from I/O to memory to CPU, even to some cool like network, at least tagging network, and then you can use other tools to control it. But it's another really powerful side. So it's not there for segmentation. It is there for workload management, making sure people get the resources that they're supposed to get. So that's our second tier. And then the third tier is SELinux. Now, SELinux, I know Dan Walsh really well, so I can make a little bit of fun of this. SELinux, when I was in IT, 5+ years ago, SELinux was a challenge. Like, you turn SELinux on, and stuff would break. And part of that was, you're trying to customize SELinux to these very handcrafted systems. That's what I was dealing with, at least. And the policies were evolving really fast, too. So it has gotten better. You would try it. But I'll explain why it worked really well for us on OpenShift, where it hadn't necessarily worked for me in the past before. Step one was we sat close to Dan Walsh. It's like, we can't turn it off. Like, we've got to give it a try. So that's like my plead number one. But two for us is we really narrowed the problem space. So SELinux, because there weren't a ton of people familiar with it, it flips the security model on its head. So you have discretionary access control, which basically means like, I'm going to turn off all the bad things that hackers shouldn't do. And it's a cat and mouse game. They're going to find new ones. You're going to turn them off. Mandatory access control, or MAC, they'll call it, is a whitelist approach. So you actually don't get to do anything unless we say you can do that. And in a narrower problem space like PaaS, that works pretty well because you're hosting web apps and you're running databases. And you shouldn't be messing around with shared memory in the kernel or doing crazy network adapter level things. And so we're able to whitelist pretty effectively. And this, of all of the things on OpenShift that lets me sleep, this is the one thing. Because malicious activity, like if you run a large hosted public service, you have malicious script kiddies, Bitcoin miners, everybody on there all the time. And this has been our best way to say, we're not doing the cat and mouse game, nearly as much at least, where we have a set of rules, and everybody sort of has to fall into those rules, and it's largely invisible. That's been our goal with SELinux there. So usually about this part of the presentation, I get asked the question. So I figured I'd put in a slide to get ahead of it of containers. Like, we're spending all this time on containers. What about virtualization? And for us, like, virtualization has a ton of strengths. We run containers on VMs in Amazon. I actually see the problem sets as they work together well. They're not mutually exclusive. But while virtualization is, I'm a Linux guy, but I consider it fairly mainstream now. A lot of people know what it is. If I poll a question, you're all going to raise your hands. And a lot of people have worked with it. But the downside to it is it's still pretty heavyweight. And usually when I ask people, like, how many people are really deduping memory across 2 VMs and you're comfortable with that, maybe like one hand raises up, the person that really wants to prove they've done it. So very few people have taken the overhead entirely out of virtual machines. But I don't want to act like containers is the end-all, be-all, because containers, like networking, at least today, is a lot more complex. You're sort of on this flat network. You're dealing with overcommitting resources and workload management, things that are pretty well structured in the virtualization space. Containers opens it up and adds some more challenges. But if you're in a use case like ours, where you're trying to drive density as high as possible, containers are really powerful for that. And the example I give is in Amazon. A lot of people were hot on this pay for what you use. It's cloud. It's going to change everything in the world. But the reality is, if you're paying Amazon for a VM, you're paying them whether you really use it or not. Like, if it's running 1% CPU, you're paying them the exact same amount that if it's running 95% or at your upper threshold. So our challenge was, we're going to use the public cloud business model because we are going to turn VMs on and off. But man, when those VMs are turned on, we're going to get every single drop of resources we can out of them because that's the most cost effective for us. And that's what drove us to containers as a technology. But our challenge now was, how do we interact with these things? Because you can't take at least we couldn't take the Puppet model of it's going to be state, and every 30 minutes, like, it's going to run and sync up containers, those things. We needed synchronous behavior of user asks us to create an app. We go create a series of containers or gears, and then we need to give it back to the user right then, that second. And so that was a different model, and that's actually what brought us to MCollective. And this was 3 years ago, so it was earlier days. MCollective has actually come a long way since then. But the MCollective space, how many people are familiar, like, you use MCollective here, outside of the normal Puppet use case even? OK, cool. So MCollective, it's agent-driven. You're able to define these agents and install them on the servers. And then we have sort of our orchestrator, which we call a broker, that can call out to these agents and do things for them. And for us, this was really powerful because we were like, you know what we're going to do is we're going to use MCollective to spin up these containers. So we have Puppet, and we know how to do it. We're all IT ops guys. Like, we're going to use Puppet to control our VMs. And we do have to be agile at that. We add a lot of VMs all the time. Like, no matter what, you run out of capacity, you need more stuff. But then MCollective, we added in that space of, I need a container on this machine right now, and I need to give it back to the user. But it actually went a little further from that, because for us, if you take this command at the top, which is saying RHD or command line tools, create me an app. It's called my app. It's PHP 5.3. We needed to do a few more things than just like go create a container and we're done with it. The first piece was we needed to define what machines. These are hundreds of machines. They're changing all the time. What's the best machine to put this app on right now? And the MCollective agents were very powerful in that because we could use things like factor behind the scenes to look at load and look at capacity and put a lot of sophistication in the querying mechanism and each machine's ability to self-report whether he's a good match or not and keep our broker really, really simple. I mean, really, it just says, hey, I got this PHP app and it's a small gear. Who should host it? And if it gets 5 replies back, we have algorithms pick whichever one is the best fit there. But it's a nice separation of concerns for us of all the intelligence of who has capacity, but keeping the querying mechanism really simple. The second thing for us is we find that perfect machine, and what do? Like, we got to run something on it. In our case, it's go spin up the cartridge. You need to go copy a bunch of configs from PHP, start services. You might want to restart, stop, any of those things. But the key part is it also controls those commands. Because if our brokers, our orchestrators were ever exploited, we really rely on MCollective to make sure that you're not installing new packages. We don't want a lot of operations. We don't want basically a remotely distributed root account on all of our nodes. And so that power of control, of being able to say, I can write a very rich agent, I can limit the function and provide a lot of sophistication of those functions, and then have some confidence that, one, there's built-in validation, all sorts of things within the calls, but you also limit the scope and your potential attack vector of what can be called against that. So that was a powerful combination for us there. So MCollective really grew into we're not just going to use it to set up the machines. We're actually going to use it for every single interaction we have on these. If you went into OpenShift and restarted your app, that's going to be driven through MCollective. If you went in and added a new cartridge, that's going to be driven through MCollective. It is our messaging bus infrastructure between our OpenShift orchestrators and where all of the apps are hosted. And all of the things about like dynamically querying the network state, those things are very important for us because our nodes are volatile. Like we add them and we compact and take them away. And when you're dealing with thousands of apps a day, that stuff happens a lot. And so MCollective is very resilient to being able to broadcast and query, find things, and then run pieces on them. So the other question we go with a lot is, why use MCollective versus pick your technology? There are some in the same space. There are some you could add together to get there. But for us, the number one thing was the agent development of being able to, it was just faster to build an agent with MCollective than it was to do it ourselves. They were richer. They had more functionality, like validation that we just got out of the box for them. But it was also pretty robust. Good docs. I mean, this was 3 years ago. Like good docs, really quick starting point for us. The second piece for us was it's built on messaging. And this we actually know intimately well because when we started, we took the messaging tier out and we wanted to do AMQP over Apache Cupid. And MCollective has a phenomenal separation between what it provides on top of messaging, and it does not mandate the messaging infrastructure in any way. And since then, we've actually moved back to ActiveMQ because they keep adding cool things in the ActiveMQ tier, and it was faster to follow that track. But the fact that you're built on a messaging backbone is really important to us because for us, that means we're learning and we're securing the messaging tier. And it's a lot easier to do that on something that's pretty well known, like ActiveMQ or Apache Cupid or any of those, versus something that's buried deep in a product. The last piece for us is with security, it adds a nice layer on top of it. So we're going to secure the message broker. We're going to secure our boxes. We're going to harden them, do all those things. But then MCollective, basically for free for us, and this added layer is going to add things like message signing. So that's harder to inject stuff onto the message brokers themselves. It has auditing capabilities, inventories, just a bunch of things that you get for free by buying into that infrastructure. So those were the three things, like the key points that really separated MCollective as a technology from a lot of the other lower level or other offerings that are out there for us. So one of the last things for me is, and I think about this all the time. Usually, having been in the technology space for a while, if I look back on choices we made 2 years ago, I usually want to change them. Like, I like technology. Replug in again? Yeah? Sorry about that. I like technology. Technology changes amazingly fast, except for display technology. I've really had a bad string of luck with displays lately. It's the one thing. I didn't do any live demos this time. So like, you know what? I got to get projectors working again, like in my presenter mojo, before I start doing crazy live demos. Any idea? Anything I can do differently? Let me try one more time. But I will talk while I do this. When I typically look back on decisions we make, I want to change them. This is an area where I look back, I would not change our decision to focus on containers. I would not change our decision to use MCollective as that tier. And that's lasted for 3 years. That's like a lifetime, and especially in PaaS, right? Platform as a service, that we can use all the cool new technology. So it really has had staying power for us, which I tend to look at like some of the best decisions we made fall into this foundation. So for us, it's not just the new technology. There is new technology every single day. The power that MCollective brought for us and Puppet is that it sort of gave us that way to harness them. Containers are cool. I love them. I'm an OS guy. Like, I read kernel books. But if you don't have a way to use them well at a large scale sanely, then they start not being as cool and start being a big problem child for you to learn. And so the combination really made that powerful for us. Put in a bunch of links here to, if you're interested in this, you can find everything, at least good docs and everything, including SELinux. Those of you that are the set and force zero, I saw that. Great doc. It'll get you started on that. And then this is Reveal.js, great framework. This is running on OpenShift. Sources out on GitHub if you guys want it, and all the attributions for the photos. So that's it. Sorry I rushed through the end, but I didn't want to do another projector replug. What questions? Any questions you guys have? I'm more of a managerial type now, but I developed for like the first 18 months on OpenShift. So if you have any techie questions, I'll do my best at answering them. Sure. And I was asked if you could use the mic too. So whoever can race to the mic first gets wins.
What can you tell us about MCollective scalability?
Oh, it's OK. That was all my slides. So for us, when we started, the one thing we worried about with MCollective was the broadcast pattern, because they're pretty big into like everything you do broadcasts to a bunch of machines. And in our world, we're like, man, this is definitely going to be in the hundreds of machines. Like, at what point is this going to tip over and fall? One of the downsides is we tend to, solve the problems that we know we have to solve right now. So what I can say from the scalability is we run in the hundreds of machines, and it's volatile, and MCollective is not my problem child. That said, it is a worrisome thing, especially the broadcast for querying makes perfect sense. Once we've picked a machine, I would love to only have one thing going across the wire to that machine. So those are some things we've actually looked at trying to contribute into MCollective, because you can do that at the messaging tiers below, but I have a long list of things that I keep meaning to do. So it hasn't burned us. It's worked really well, but that concern always looms in the back of my mind.
I have a couple of questions.
Sure.
Do you recommend people running production applications in containers?
That's a great question as well. So for us, we're a unique company, because when I have a problem with Linux containers, like, I go walk down the hall to the guy doing the cgroups commands. I'm like, hey, Vivek, like, fix this for me. So being at Red Hat, it's a little bit different, where it is a very bleeding edge technology, but I have that support system inside the company to run and make that work well. I'm a biased party, but like, we try to make containers able to be run in production through something like OpenShift. It's a fixed use case. We do them one and only one way, and we think we do that pretty well, and we support it. If you were going to go start tinkering with kernel namespaces yourself, it's certainly doable. It's very powerful, but I don't know. It would depend on your depth of knowledge at the OS level, because it's still pretty, it's low-level pieces there. So.
And the second question is, do you support multi-tier apps that actually span multiple containers or VMs?
We do, and I'll answer that question in two parts. So one is usually, when I say we scale in OpenShift, does that mean like on a single node we spin up containers, or can we span multiple nodes or VMs or models? So the first answer is yes. And in fact, for us, like when we scale in OpenShift, we always try to put your gears on other nodes, because it improves our resiliency. If you lose a node, you're not going to lose your whole infrastructure there. The second question is around multi-tier type stuff. So now I don't just have a PHP app. I have PHP and MySQL there. And can you put them in separate gears and scale them differently? And that answer is yes, with an asterisk on it of we do two-tier type things really well today. Could you set up any arbitrary complex topology with OpenShift with our cartridges? That's what we use cartridges for. Maybe, but it's going to be some work. Can you do two-tier and three-tier type things fairly simply? Yes. And we do in that model, like if it's a scaled app, we put them in separate gears, we scale them differently, all those sorts of things too. So.
Are you agnostic to the hypervisor technology, or?
And OpenShift specifically, we run anywhere that RHEL runs. And so a lot of times I get asked, like, well, why'd you guys pick RHEL? You're Red Hatters. And actually, like, getting the combination of SELinux policies and control groups and all those things tuned and working, it is a low-level OS dependency challenge. And so that's why we work on RHEL. But any hypervisor that can provide supported instances of RHEL, it works on fine. That could be bare metal or virtualization for OpenShift.
And, what are the changes I need to do to my app to deploy it using OpenShift?
My marketing side of me would say nothing at all. That's
why I said
that's our hope. The engineer side of me says, like, man, we try really, really hard to get that 80% where you're not going to have to change anything. Almost guaranteed, you're going to have to look at environment variables for some data that you probably assumed. For example, like binding to 127.0.0.1. We can't give everybody 127.0.0.1 until network namespaces is in that tree, which it's not. So we give you your IPs through environment variables. Usually it's a very simple change, depends a lot, but catch me at the conference, right? If I'm the guy you can yell at. If it's not a simple change, yell at me. I'll in turn yell at somebody.
Thank you.
Okay, no problem. Any other questions? I talked fast. I told him I talked fast. We have a little time. If nothing? Is it because I didn't bring swag for you guys? There's one. Okay. Yeah, that's right. The real swag.
How about a little bit more detail? Are you able to share any of the modules you guys are using, or do you want to go over some of what you've done in those modules for managing this?
So the modules are out on GitHub. That link in my presentation, you'll go to them. So in OpenShift, I'll give you guys a little background. Like, we have 3 offerings, basically. We have where we started, which was what we call OpenShift Online. And that's a hosted service, very similar to a Heroku or a Google App Engine, where you just use it, we manage it, we're on pager, rotations, all those things. But we're Red Hat, and so we didn't want to just be in the hosted model. And so everything we do in OpenShift Online is also open sourced with, it's called OpenShift Origin. All our Puppet modules, our MCollective stuff, everything we do is out on GitHub. It's ASL v2 licensed. We have Google Plus communities, everything around OpenShift Origin. So there is we're doing a tech meetup on our use of libvirt. Actually, I think probably today. So we do a lot of stuff in the OpenShift Origin community. I sprinkled links through this presentation, so if you want to go back and look at that. And then we have OpenShift Enterprise, which is very similar to Fedora to RHEL. OpenShift Origin is like Fedora. It moves 100 miles an hour for us. So if you want to be in the business of managing a PaaS, that's where we like people to work. If you just want to run it internally and you want it stable and you want life cycles of those things, that's OpenShift Enterprise for us. So does that help? I'm too shell-shocked with the projector to start tooling around on GitHub. But if you want to catch me afterwards, I will bring it up because all the stuff's out there. Yep.
So what kind of applications have been deployed? Like, is it just, web tier applications or other kinds of applications have been deployed?
It varies a lot. I would say the vast majority of what we see is web-based applications. That's just percentage-wise the easiest thing. It's HTTP, it multiplexes well, like all those sorts of things. And in fact, within that, I would say horizontally scalable web applications is the easiest thing to go deploy in a PaaS. Now the challenge is, like, when I was in IT, horizontally scalable, simple one-tier web apps were the things you wished you were managing, but they were not the things you ended up managing, where they were not horizontally scalable. They were running on older application runtimes and those things. The reason we picked like SELinux and Linux containers is we can be very agnostic to what runs in those gears. We don't care. It can be a C or C++ application. It can be JBoss. In our cartridge here, we do stateful networking connections. So we can spin up like an EE6 container. And as it adds more gears, it'll span the cluster. So we get much closer to traditional apps there, but there are always constraints to it. But that's in the web app tier, where I would say we have 80% of what I used to deal with in IT I've seen deployed in that manner. But my favorite story is from, this was probably 2 weeks ago now. We work with our ecosystem a lot, and other people can build cartridges as well. That's what we want to happen. And we had a database provider where usually, like you ask me, I carry a lot of scars from MySQL master and master slave configurations. Still a little tricky, like it just doesn't turn on and turn off like cloud style. And so we had this company that was like, you know what, guys, we think we can solve this using your cartridge infrastructure. Like, we know MySQL well, it's going to be great. And my first thought was like, wow, that sounds fantastic, because I don't think I could do that with our cartridge infrastructure. It's hard enough with HTTP-based web apps. And these guys actually came back and said, they're like, well, we took your HA proxy cartridge and we added our own routing tier in there and here, but demos speak 1,000 words, so we're going to go spin up our master and a tree of slaves on here. Go kill -9 whatever you want, and here's the query stream going against that. Their proxy instance for it. And it worked. And I'm sure there was a little bit of hand-waving going on behind the scenes, but that was my best example of something that 2 weeks ago I would have told you probably wouldn't even work. Like, there's just too much low-level networking, those things. And so it was a high point for me. We are starting to see much lower-level things that are able to run in this environment. And the next round of kernel updates, like in the RHEL 7-ish timeframe, containers just gets that much better, where you will really start to see low-level software that can run without any changes. And so that's the second thing that I think will be network namespaces gets into that a lot. Does that help? Does that answer it? Okay.
Anybody trying to use Hadoop?
There is somebody, and I had actually worked with him. He was asking about MapReduce, and MapReduce type algorithms work wonderfully in that, because what we're good at is giving you as many smaller resources as you ever need. I mean, we just won't run out of them. Like, we have that infrastructure base now. And so to me, MapReduce is a perfect fit for that. You can break workers out and bring them together. I know somebody who's working on that. I didn't get a fancy demo or anything, so I don't know if, but what I do is I'll search for OpenShift, insert technology of your choice. And you'll usually find like a quick start or a cartridge or something that's out there. Be warned, varying quality. Some of them come all over the place, but most people you got something out there about anything. Okay, we got a couple minutes left. One more. Any last question, answer? Keep looking. You have one? Or yeah? Okay.
The numbers that you showed in the keynote are like totally, incredible.
I'm
just curious where you got so many of them.
Which ones? So we showed 3 in the keynote.
All of them are mind-blowing.
The million apps deployed on OpenShift. Well, I would love to say like that just came easy, to have magic, but we work hard we're at every hackathon, we're working with developers, we work with a lot of companies to make sure that user experience is phenomenal. Because at the end of the day, like, we're competing with other really good hosted PaaSes. But the thing that it showed me is the interest levels are really high too. You have that much inbound traffic. When we started and we were tiny, I would really look at like, how many did we get today? And looking at the types of usage, and it is too high now. The traffic, the 500 million plus hits a month that we serve out, that's much more testament to our users than it is to us, because that has shifted of when our users have started running real apps that are getting real traffic. So, in the days of the Hello World days of PaaS, you really didn't have too high traffic numbers. You had a lot created, but they weren't driving a lot of traffic. And now that's more, I can't take any credit for that, other than the thing works well enough for them to get that. And the new apps created every day, I mean, it's a lot of sweat and going out and making sure that if somebody complains about something, you get it fixed. But it's fun. I wouldn't have guessed 3 years ago that we would be saying those same numbers as well. So, yeah. Okay, well, that's it. I will not awkwardly ask any more questions up there, but I'll be here at the conference. I'll probably be at the booths. Catch me if you want to see any of this stuff, and I will give cavalier live demos, too, if you catch me out. Won't do that up here, though. Thank you guys very much.